is variables, the most basic thing we work with. Variables. We can also call that computer memory, because that's really what it is. Variables is just a way to index and reference the memory that's in the computer, and which we use to make any program interesting, more or less at all. I mean, if you take your basic, the code you wrote to draw an avatar, that actually doesn't use any state. I mean, the computer doesn't need to remember anything, apart from the code, of course, to be able to do that. But to do anything interesting, like a game, for instance, then you need to remember what state the game is in and use variables for that, which is just pointers in the computer memory. So, let me draw a representation of computer memory, a model, you could say. So we draw a grid. It could be, a grid is just one way of putting it. Computer memory really isn't two-dimensional at all. It's kind of one-dimensional, you could say, but it's a good way to think about it. So we just assume the computer has a huge sort of scratch pad where it can write stuff, right? And when I say write stuff, it's computer. It actually just writes ones and zeros, as you know, binary numbers. We usually use numbers just to, let me just, this one. Here we have a 12 in this memory cell here somewhere, and here we have maybe 54. Those are just that's just random stuff. And what we do with variables is that we give them a name. So let's say this is Minecraft we're looking at. This number 12 is actually Steve's number of XP. So if you run Minecraft on your computer and you look at the memory, then there is some cell somewhere that actually stores how much XP Steve has, and it's just one cell that's used for it. Although it's a big game, it's really as simple as that. And let's say this 54 is maybe Steve's health. Well, he is 54% health, something like that. And a bit of color. So we put some color on. Like this. A little bit less. Those pointers are actually nowhere to be seen. Oops, no, let me. They don't have to be anywhere. It's just for us to remember it. It's maybe in the program code, but it might not be noted in the computer anywhere. It's just something we use when we program to refer to stuff. Let's say that now we actually write this in Java code. And Java, Minecraft is actually written in Java, so it's probably very close to being true. Like this. As you see, this looks exactly like processing, and that's because processing really is Java. P equals 12. So we call that initialization. So when we declare the variables, that's very important, declaration, we declare this variable, Steve health, Steve XP, we also initialize the values by putting this equals 54 and equals 12. And the computer writes those values in those cells, and they stay there until they are read again or changed. Now it's also mentioned in, there's another analogy in the book, which is like a scratch pad or like a scoreboard maybe. So I'm just going to put that over here just to illustrate these changes. Steve's health. xp, like this. And then, because these values can change many times over time, of course. So let's say it starts out by being 54, that's the initial value, right? And then maybe it becomes 50 at some point, becomes like 28, becomes like 4, minus 5, he dies. And let's do the same for xp. That usually goes up, so maybe like this. And the point is that the memory cell doesn't remember this history. Okay, so first it's 54, and then we want to change it now to 50 because Steve got hit by a zombie. Well, the 54 is erased, and now the cell will contain the value 50 instead, and so on. So this is erased at some point, this is erased at some point. So it's only the last value that's in the cell. Exactly like this. The memory in the computer doesn't remember this, it just vanishes. There are some people who actually imagine kinds of computer memory that would actually remember the history of everything that happened to them, but that's more sort of exotic. It's not very real. It's not what we use. Yep, I'm just gonna save this. So it's, you can also look at it later if you want. It's actually 7. Okay. All right. A little example. Let's do a little example. So since we're doing, oh, this is typo, I'll fix that later. Since for some reason we're doing classic games, I don't know why, but it happened. We have this very classic game. Let's talk about if we were to program this. We had an idea, we want to make this Pong game. One way of going about it is to think about what variables would we need to store the state of this game. Any ideas? You were first?
Scoreboard?
The scoreboard, yes. So what exactly?
The amount of points you gather.
Yeah, yeah. So what kind of variable would we store that in?
Integers?
Yeah, how many? How many integers?
Digits, I think, or 2.
Yeah, 2 probably. So let me just put that. I'll call this one, this variable, I'll call the left score. And this one I'll call the right score. And maybe just some lines. Yeah. Anything else? Yeah? Colliders?
Between the ball and the spider.
What would that be exactly?
You have to make some kind of thing so whenever those two attack and it goes out to the
Yes. That's actually more like the behavior of the game and not so much the state. Yeah. So what we're looking for is what do we need to remember about what we see in order to run the game. Let's try you.
Player 1, player 2.
Player 1, player 2. Yeah. What kind of variables would those be?
Because of the left player and right player, I don't player 1, player 2.
Integers, floats.
Oh, integers.
What would they
What would
represent?
they store here?
I'm sorry, I should maybe. I think you're a little wild track also, because you mean the bats actually.
Yeah.
And what do we need to remember about the bats? What changes?
Y-axis, I guess.
Yeah, yeah. That's correct. I would say the Y position of the bat that would be a good candidate for a variable because they are moving up and down, right? So I call this left y, and this one we call right y, and a little line. I mean, the rest is not really a variable, like the x position of the bats, that's not really a variable because it never changes. So it's like a constant, we call that a constant. So we could put that in the code, say the right bat is like at position 10, or just write 10 in the code, we don't have to give it a name. Anything else? Yeah?
The x and y of the ball.
The x and y on the ball. Yes, the ball moves around a lot, so we need to restore its position, and that's probably, so that's like 2 variables?
Yeah, that would be 2 integers.
Yeah, it could be. It could be integers.
Could be floats for safety reasons.
It depends on the implementation of the game,
Yeah.
but usually the way we work is probably floats. So let's say ball x, ball y. Yeah,
We could make some for the height and width of the screen.
yeah. Does that change during the game?
You could change it if it was a game. You could like break it out and make it bigger.
Yeah. The point is that yeah, you could do that, but in the old Pong game you couldn't. So
Oh, okay.
so those are not variables in this case. Let's have someone else.
The direction of the ball.
Sorry.
Which way the ball is going.
Yes. Very good. Direction of ball. Yeah. How many variables would that be?
X and Y.
Yeah. Yeah. What type? What would be? Let's say we have the ball direction x. We call that, and that's like a float.
It's a plus.
Sorry.
It's X plus something.
Yeah. It's the increment or the change in the ball position, maybe every frame or every second. Very good.
Let's just call it velocity. Let's just call it velocity too, or speed.
Yeah, we could do that.
Maybe it'll be clearer.
I'm gonna write both because it's. I mean, the thing is that in Pong the speed is always the same. It's a constant speed. But you are right. I would probably call it that also. Yeah.
Actually, it can be changed. The speed.
Yeah, but the original Pong is no.
Yeah.
That's,
Yeah, in that game the speed is always the same, but why then having a variable if it's always the same? But it does change. I mean, in this case, it's just the sign that changes, right? So it's either positive or negative in both. That's how the ball goes in these diagonal. So let's put that as well. Yep. And 2 little lines, and then we're done. Yep. Anything else? Yeah?
If statements for when you are scoring, so if the ball is at x1, then the right player gets 1 point.
Yeah, I mean that's again not the state, that's the behavior of the game. So that's the code, you could say. So, but it's good that no one knows because there shouldn't be anything else. I mean, this should be the complete state of this game. So we want to know where the ball is and what direction it's moving in, where the bats are in the height, and what the score of the players are. And that's pretty much it. Let's store that. Yeah, so a little bit more about variables. Oh, it's like this. Variable, something called declaration, and what I mentioned before, initialization, and this word type. What do we mean when we say this? I mean, there's a lot of, oh, oops, I noticed that. Okay now? Yeah. These kinds of little words are actually really important in a topic like this. So then there will be a number of words that I explain about, and in a technical topic like this, these little words mean everything. So it's very important sometimes to use the right word. In this case, declaration, initialization, and type, they're very important little words. And I mean, you could probably use another word for it, but you don't usually because you get misunderstood. Let's start with the last one first. Type. This is the kind of data, you could call it. Kind of data in each variable. It means that every variable has a type, and we have a bunch of different types we can assign to a variable, and each one only has one. And you already, many of you obviously already know some types. You said integers, which are called whole numbers. I think this is what they call them in the book. This is called int in the programming language. And then these floats, that's another type, decimal numbers. That's called the word float, number with decimals. Then they mention, I just put it here because it's in the book, we don't use them so much, but there's characters. So you can have a variable whose value is a single character. An example of that is like a key from the keyboard. So which key did I press? I pressed the A key. So the value of this variable is A. And then we have these true-false variables that are actually quite important. And they're called Booleans, from a mathematician who came up with this a long time ago. Boole, I think was his name. Boolean is a variable that can only have these two values, either true or false. So every variable has a type, and that's when you declare it in processing, that's the first word you write, that's the type. So int something, float something, boolean something. Declaration, what happens when we declare stuff is really that we allocate a memory cell in this huge grid in the computer. So when the computer sees, now I want to declare a variable, it actually says, okay, I have this cell free, I will allocate that for you. From now on, the value of this variable will be stored in this cell. And yeah. Just grab this. Let's see. Oops. A little bit of trouble. Move it up a little so everything fits. And this grid, maybe a little smaller. Yeah. Just to sort of hammer it out with nails. Maybe an integer variable called xp. Maybe a float variable called health. Maybe a character variable called key. or a Boolean dead. Is the guy dead or not? This is the declaration, right? So we write this, it's the declaration. We declare the variables. And as I said, what happens is the computer allocates a cell somewhere. So it reaches this int xp. Okay, there's a nice cell here. Let's do that. We allocate that for this. And then float health. Well, maybe this one. I mean, we don't really know which one it takes, and we don't care about it. It's the computer's job to allocate this for us. We never really know where stuff is, very rarely at least. This one. Char key. This one maybe. Boolean dead. So Boolean actually takes like a whole cell. I mean, it's like it can only have 2 values, right? So it's kind of wasteful to do that. And of course, you could save on it, but just to say that it's one cell that remembers just a single Boolean value, which can just be either true or false. Okay. Initialization. That just means assigning an initial value to memory. Oops. So we actually usually do that at the same time as declaration. So just to illustrate the difference. So by putting these little, it's like an assignment statement. It looks like an assignment statement, but it's not. It's initialization.
This statement actually does both declaration and initialization. So D equals its initialization.
Yeah. That would just put these values like 0 here and 100.0 here and so on. Okay. One more slide and then maybe a small break. Expressions, so using variables and assignment. Yeah. A calculation which results in a value. Again, it sounds very straightforward, I guess, but it's line on that. There. This is what we mean with the word expression. An expression is also one of these words that are important because it means a very particular thing in a program. Usually in all the assignment statements in the program, it's everything that's on the right side. Those are always expressions. And some of them are very simple. So it can be difficult to see that they're actually expressions, but they are, because the rules are exactly the same. So 20, that's an expression in this case. That's a valid expression. It's a very simple one, it's a constant value. X plus 10, that's another expression. X plus 4 times y. X minus 2 times mouse x plus 4 minus mouse y. Yeah. So arbitrarily short, arbitrarily long. Anything like this is an expression, and it's really a calculation. It's just like when we write an equation in math, we could calculate the value of it, and the value is sort of the output of the expression. The expression always has a result, a value, something that it evaluates to. The point of variables in this case is that we can use variables in an expression. We can read the value from them. We cannot change the values inside an expression normally, but we can read the value, we can use it anywhere in the expression. More than one time, that's fine as well. The most basic place we use these expressions is something called an assignment statement. Again, an important word, especially important to spell right, like this. Assignment. A equals x plus 10. And a semicolon. The left part is always the name of a variable. Okay, and the right part is an expression. So this a here, that's the variable name. And this x plus 10 in this case, that's the expression. Again, it can be short, it can be just a literal number, like a equals 10, a equals 0, or it can be like an arbitrarily long thing like this, a equals 10 lines of stuff. All that is valid. Usually not a good idea to use 10 lines for expression, but it's possible. When the computer sees this line, when it reaches this line in the program, what it does is it first takes the right side. It always starts with the right side. It evaluates this expression. It finds out what is the value of this expression, the result. For that, it needs to look up in memory what is x, so the value of x, and it adds 10, and then that's the value in this case. And then after that, after evaluating the right side, it looks on the left side, see we have a variable called a, we should assign the result to this variable in memory. So that assigns this variable in the cell that belongs to a, the variable a in memory. The other main place where we use these expressions is in a function call. A function call can actually sit inside of an expression. But the way you use it mostly is as a separate statement in the program. So for instance, this line 0, 0, x plus 15, y times 2.5. Yeah. This line here, that's a function call. It's a statement that runs this function. And before it does that, it needs to find out what the value of all the parameters for the function should be. And each one they are separated by these commas. And each of these little parts here, those are all little expressions. Some are littler than others, like 0, very small expression, or y times 2.5, that's slightly bigger, right? Just put some. So this is an expression. This is also an expression. This is an expression. And this is an expression. Okay. I'm gonna get my screen capture stored. So do like this.